Data transmission within a computer system. Data transmission within a computer system involves the movement of data/information between various components such as the CPU memory, storage devices, and input/output devices. This process is vital for the proper functioning of a computer and its ability to execute tasks efficiently. The following points give an overview of how data is transmitted within a computer system. Bus architecture. Computers use a bus architecture to transmit data. A bus is a communication pathway that allows the transfer of data and control signals between various components, such as the CPU memory and peripheral devices. It is just like a highway system for data inside the computer system. There are different types of buses. Data bus carries the actual data being transmitted. Address bus specifies the location in memory or I/O device where data should be read from or written to. Control bus carries control signals that manage the data transfer process, for example, read, write, halt, etc. Data paths. Inside the CPU data paths are dedicated paths known as data circuits that facilitate the movement of data between various functional units. These functional units include the arithmetic logic unit, ALU registers, cache, and other components involved in data processing. The data paths allow the CPU to perform operations on data by providing routes for data to move within the processor. Data paths are more internal and pertain to how data moves within the CPU, while bus architecture addresses the broader communication infrastructure that enables data transfer between the CPU and other parts of the computer system. Details are shown in Fig. 1.36. Registers. Registers are small, high-speed storage units located within the CPU. They hold data that is frequently used by the CPU during processing. Data is quickly transferred between registers and main memory via the buses. Memory hierarchy. Modern computers use a memory hierarchy to improve data transmission. Data is stored in different levels of memory, ranging from high-speed but small cache memory to larger and slower RAM, and even slower secondary storage, hard drives. The CPU fetches data from the higher levels of the hierarchy, first due to their faster access times. Instruction cycle. When a program is executed, it goes through a series of steps called the instruction cycle. This cycle involves fetching the next instruction from memory, decoding it to understand what operation is required, fetching operands from memory or registers, executing the operation, and storing the results back in memory or registers. It is called fetch, decode, execute cycle. Pipeline processing. Many modern PUs use pipelining to increase efficiency. In a pipeline, multiple instructions are in different stages of execution simultaneously. This allows for better utilization of the CPU's resources and faster execution of instructions. Interrupts and I/O input/output devices, for example, keyboard, mouse, display, network interface, communicate with the CPU using interrupts. An interrupt is a signal that halts the current program's execution to handle an important event. This allows data to be transmitted between the CPU and these devices. Parallelism. Some computer architectures use parallelism to improve data transmission speed. This can involve multiple cores within a CPU or even distributed systems with multiple interconnected computers working together.